tan theta equal to tan upon c. Let me first write perpendicular, that means BC upon AB. That means tan upon 8 is 5 upon 4 is the first equation. Now in a right angle triangle, second one, this one, tan theta is equal in right angle triangle PQR. Let me take tan theta is equal to, this is also tan theta we are calculating, this upon this is equal to h upon, first let me write the size, which is QR or Q upon PQ. That means this is h upon 30. The second equation. So from first and second equation we see tan theta, this is 5 by 4, and here it is h by 30. From first and second, from first and second we have, just 5 by 4 is equal to h upon 30, or h equal to, or h height of the tower is equal to 30 into 5 upon 4. 30 into 5 upon 4. So 2 to the 2, 15 times 15 5 is 75, right, upon 2. That means the value will be 32.5 with 3 ja 75 is 2 3 ja 6 and 1 carry 2 7 ja 37.5 meter. This is the height of the tower, 37.5. For these two triangles, similar triangles, so their corresponding sides ratio will be same. This upon this equal to this upon this. Angles are equal at the same time. This angle is similar to this. Theta, this is theta angle, tan theta we have calculated that we have equal, and after equating them we get h equal to height of the tower is equal to this one, 37.5 meter. Okay, this is the answer to question number 2 completed. Now let me take the next question. Now question number 3. Question number 3 now. What question number 3 says? Let me first speak that loudly, and after that I will solve that question. Find the height or distance or whatever is required. This is question number 3. Question number 3 says, question 3 says, this is third question, third question, or question number 3 says, find the height of a tower if the angle of elevation of the tower is 60 degree and the horizontal distance from eye to the foot of the tower is 100 meters. Alright. So we have to find the height of the tower. We have to find the height. We find the height of the tower. Find the height of the tower. It says, if the angle of elevation, is 60 degrees, one thing. Secondly, angle of elevation is 60 degrees, and the horizontal distance from the eye to the point of, let me take, this is the tower here, and this is the eye. Okay, from this eye is the eye here, and this is the top of the tower. Now it says, put the height of the tower. Find the height of the tower. Just suppose this h is the height of the tower. And let me take PQ, the tower, and R. R is the point of watching point, you may say. Find the height of the tower. If the angle of elevation of tower is 60 degree, this is 60 degree here. Angle of elevation. Watching towards height. Okay. And Q is the height with the point of the height of the top of the height of the tower. And the horizontal distance from the eye to the foot is 100 meters. Now this is 100 meter given to us. This is distance on the ground of the foot of the tower. This is P, the foot of the tower. From this point of watching or eyeing point, ground station by this one table 60 degree, and the horizontal distance from the eye to the foot of the tower is 100 meters. This is 100 meters. Okay, length on the ground, distance on the ground from the foot of the tower to the point of watching or eyeing point, the eye, from where we are watching the top of the tower. Now question says, what is the height of this? Okay, again this is solution. What we see, let PQ is the PQ equal to H is the height of the tower. Is the height of the tower. Okay. RP is equal to 100 meters given, where R is the point of eyeing or watching point. From here the point is given. Angle QRP is equal to 60 degree. Angle of elevation given. Okay, so in right angle triangle PQR, we have again height is to calculate tan theta. Tan 60 degree is equal to PQ perpendicular upon base. Base is RP. This is PQ means height H we have taken divided by 100 meters. Okay, this is equal to tan 60. Tan 60 is root 3. Since tan 60 degree we know is equal to root 3 value. Therefore, it's implied that H equal to height of the tower equal to 100 root 3. Just put either in square root 3, this is meter value, or if I substitute the value of root 3, which is into 1.732. Okay, so this decimal point will go ahead. This is 173.2 meter. Put answer 173. Okay, this much MVTR, this much meter. So 173 meter is the answer here. This is height of the tower. Question number 3 we have completed. Let us take question number 4 now. What does question number 4 say? Let me check that. Now question number 4. So angle of elevation, angle of depression, you must understand that. What is that angle of elevation or depression means? After that we can draw the graph easily. Question number 4, let me share. Now it says a balloon is connected to a meteorological ground station by a cable of length 200 meter, 215 meter, included at 60 degree to the horizontal. Okay, this is station by a cable of length 200 meter, included at 60 degree to the horizontal. Determine the height of the balloon from the ground. Assume that there is no slack in the cable. Okay, the balloon is connected to a meteorological ground. Let me take here. Here is a balloon. Let me take this balloon like this. Now this balloon is connected by a rope or something. The balloon is connected to the meteorological ground station by a cable. This is cable here. Okay, by a cable of length 200 meter. 200 meter cable. No slack is here. It is straight length of the cable. Now this is the balloon here. Meteorological balloon is now here it is earth station, meteorological station on the ground by a okay and inclusion, and this is angle of at angle 60 degree. It may be at angle 60 degree. Balloon is connected to meteorological ground station by a cable of length 200 meter at 60 degree with the horizontal. Okay, so this angle of elevation, this is angle of elevation here, 60 degree, at 60 degree on the ground to the horizontal line. This is the horizontal line. Horizontal line. To the horizontal line, let me take this is P, Q, and this is R here. So PR is the cable here. The length of the cable is given to us. We're going to find out. Now it says, assume that there is no slack in the cable. Undoubtedly, determine the height of the balloon. So at what height the balloon is, this is height of the balloon we have to find out. What is the height of the balloon? Let h is the height of the balloon. Let me take the balloon. The balloon is at R and the length of the cable, attached, is PR is equal to 200 meters given, and angle RPQ is equal to 60 degree is also given. Right, these things are given to us. Now height we have to find out. At what height? To find the height. Find the height of the balloon. Find the height of the balloon. This is required here. So this is solution we are finding out. So in a right angle triangle. In right angle triangle, this is a right angle. Height of the balloon RQ we have taken. Let QR is equal to H, height of the balloon. Okay. So in a right angle triangle, PQR, we have. Now we have to find out this perpendicular, that means height. So we take it as QR perpendicular upon hypotenuse. Whatever is given, this is PR or RQ, let me take RP is equal to sine 60 degrees. Sine theta is equal to perpendicular upon hypotenuse. This is hypotenuse, the side opposite to right angle triangle. Right angle, side opposite to right angle is known as hypotenuse. Perpendicular angle, the side opposite to the angle which we are considering. The angle 60 degree is being considered. Sine 60 degree is equal to h upon 250, or this is h upon 215 equal to sine 60 degree. Sine 60 is root 3 by 2. This implies that height of the balloon is h equal to 215 root 3 upon 2. Okay, so only this much we can write. Or if I just divide it by this 2, it will be 107.5 into root 3. And if I multiply by root 3 value, which is 1.73, 2, then it will be in exact value, exact numbers. Okay. That exact number can be calculated. That is not a matter of discussion. If I multiply this by 107.5 into 1.73, 2. There are 4 digits here. Let me multiply them. 107.5 here multiplied by 1732. I'll take after 4 decimals. 1 point here, 1 point here. Let me multiply them. Okay, so 510, 0, 1 carry. 7 14, 5 15, 29 and 130, 0, 3 carry. 2, 0, 0, 7 5 35, 7 3 21, 35 and 21, 6, 56, 56 plus 3, 9, right? And 5 carry. Now 2 and 2, 5 and 5, 7, 3, 0, 0, 7 7 49, 49 plus 7, 56, 56 plus 5, 56 plus 5, 61. This is 61, 6, 1 carry. Now 3, 1 is 3, 7 is 7, 10, and 0 for 10 plus 1, 11, 1 carry. Then 7 is 7, 1, 1 0 into 0, 7 1 is 7, 1 8, and 1 1 is 1. This is the value, only answer. So now decimal we have to substitute. With decimals here, how do we multiply this? 1 into 1 is 1, undoubtedly. 7 to the 2, 5, this is Vedic mathematics. We multiply directly in one line. This is multiplication by Vedic mathematics. 2 5 10, 0, 1 carry. 2 7 14, 3 5 15, 2 plus 14, 29, plus 1, 30, 0, 3 carry. Now this 3 3, and this direct. 2 0 0, 2 into 0 0. 7 5 to 35, 7 3 22, 35 plus 21, 56 we have taken, 56, and then plus, that carry was also there, I think, 56 plus 3, I think, that was 3, that was 50, 6 plus 3, 60, 59, 9, again 5 carry, that 2 and that, in this way, this is the value here. So what is the after decimal 4.181? This is equal to 181.69. 181.69 meter. Okay, this much meter is the answer here. Answer. This is meter here. Okay. So this is 181.69. This is height of the tower. This is the answer. Height of the tower is finally calculated. Let us take next question. Question 5. What is 5? Fifth question say. Let me check that. Now question number 5 is of what kind? Well, clean this so that clear view can be seen. Yes, guys. Now question number 5. Let me take that. Now question number 5 or 5th question. What is it? Now it says the angle of elevation of the top of the building from the foot of the tower is 30. Now let me take the building here. Height is not proper. This is the building here. Now, angle of elevation of the tower, it says the angle of elevation of the top of the building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot. Just a minute. The angle of elevation of the top of the building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree. The tower is 50 meter high. Find the height of the building. Okay, now there is a building here. Now the angle of elevation of the top of the building on the foot of the tower. All right. Understood the point. On the foot of the tower. So here are 2 points. Now if I take the building here, tower is higher, right angle, this is right angle. Okay, now first let me frame the figure here, then I will take the question. The angle of elevation of the top of the building from the foot of the tower. This is foot of the tower here. Let me take foot of the tower. Okay, let us take is a 60 degree. Now it says the angle of elevation of the top of the building from the foot of the tower, yeah, is 30 degree. This is 30 degree here. From the foot of this is tower. This is tower here. Let me take this is ST. ST is the tower. No problem. Now angle of elevation, this is 30 degree of the building. Now this is the building here. We can take a different kind of building, no problem. Now this is the building here. Okay, let us take building. This is tower. Now it says from the foot of the tower, the angle of elevation of the top of the building. Which one? Yeah, the angle of elevation of the top of the building from the foot of the tower is 30 degree, and the angle of elevation of the top of the tower from the foot of the building is 60 degree, and this is your 60 degree. This is 60 degree here. Angle of elevation of the top of the tower from the foot of the building is 60 degree. The tower is 15 meter. Okay, tower from the foot of the building is 60 degree. The tower is 50 meter high on the height of the building. Okay, and tower is 50 meter high. Height of the tower is given 50 meter high. Now we have to find out what is the height of this building. So height of the building is to be calculated. No problem. Let us see. Now this distance between the building and the tower is not known. Let me take this as x here. Otherwise there is no need of this, but even then let us take. Okay, so this is the building, this is the x here. Now if any triangle is taken, then this calculate and then height can be calculated. So let us take here what is given to us. ST equal to 50 meter is the height of the tower. Is the height of the tower. Height of the tower ST. Okay, and this is the building here. Let me take AB. AB is the height. AB equal to, let me take H, is the height of the building, which we have to calculate. Is the height of the building. The solution we are calculating. Okay, is the height of the building to be calculated. This we have to calculate here. The height of the building is required. Okay, base is not given. That what distance between the tower and the building not given. No problem. Only angle of elevations are given, and this height of the tower is given. So from the right angle triangle, this tower AST. Now in the right angle triangle AST. This is the right angle triangle here. This is also right angle triangle. In the right angle triangle AST, we have this one's 1060 degree. Let me take 1060 degree is equal to this perpendicular, this is ST point here. So this is ST upon AS, which is 50 upon X I have taken. And 1060 is root 3. It's 50 upon X. There is embedded X equal to 50 upon root 3. This is first equation. Let me take 50 upon root 3. Okay, X is equal to 50 upon root 3. This is in the right triangle AST. Alright. Now to find the height of the building, which we are considered as H. Now in this right triangle, now in a right angled triangle, which one? ASB, we have of this base upon, suppose perpendicular. If I take this is cot theta, cot 30 degree. Again tan theta, let me take, no problem. That will be tan 30 degree. So tan 30 degree in this is equal to this perpendicular, that means AB upon AS, which is ABH we have taken, and AS we have taken as X. Okay, so this is tan 30 degree. Tan 30 degree is 1 root is equal to H upon X. H equal to, this implies that H we have to find out. H equal to X upon root 3. Try to understand. H equal to X upon root 3. AB is H. This is base is X. H equal to X upon. Now value of X we have to substitute from the second, first equation to the second, from first and second. Therefore from first and second we have H equal to X. X is 50 upon root 3. 50 upon root 3 upon root 3. This is equal to 50 upon 3 only. Why? Because root 3 into root 3 is 3. X value is this. X is 50 upon root 3. We have substituted here in the second equation. That is 50 upon root 3 upon root 3. 50 into 50 upon root 3 into root 3, root 3 into root 3, 3. So 50 upon 3 meter. This is your height of the building. 50 upon 3, that means 16 3 48, so 16 and 2 by 3, or 16.66, or 16 and 2 by 3, or we can write it as 16.36, 18, so 6 meter, 16.66 meter. Alright, that is because 16 3 48, 2 remaining, so 2 upon 3, 16 and 2 by 3 meter, or 16.66 meter. You can write like this. So this answer is. So finally the height of the building is calculated. This is the process. How do we calculate the height and distance of anything? This is question number 5. Let me take question number 6 now. Question number 6. Now question number 6 says, let me check what is the question 6th. Question number 6. Now it says a vertical straight tree, okay, 15 meter high, is broken by the wind in such a way that its top just touches the ground and makes an angle of 60 degree with the ground. At what height from the ground did the tree break? That's the point. And take root 3 equal to this. Let me take, this is the tree here, and it breaks from here. This is the tree, okay, a height of tree is there. The tree breaks from that point and touches the ground here at this point. This makes 30 degree angle. Okay, the angle, a vertical straight tree 15 meter total height. Let me take this is x height, and this is so 15 minus x. Why? Because total height is 15 meter, and if I consider this as x, the broken part will be 15 minus x. This 15 minus x. Let me take this is a, b, and c. BC is the broken part of the tree which touches the ground on this point C, okay, on the ground, and makes 30-degree angle. Sorry, 60-degree angle. I'm sorry. Is broken by the wind in such a way that its foot, its top just touches the ground and makes an angle of 60 degrees. Sorry, this is 60-degree angle. 60-degree angle makes an angle of 60 degree with the ground. At what height from the ground with the tree break? That is, this is the foot of the tree here, foot of the tree, and it breaks from here. So this x we have to find out. Let x be the total height. What is given to us? Total height of the tree is equal to 15 meter. Given, let the height of the tree, let height of the tree, let height of the tree up to the point, up to the point, up to the point of breaking, point of breaking, up to the point of breaking B. Breaking point is B. Breaking B. Okay, point of breaking B is, breaking point is B. Now this is x. Let me take x meter. Now at x meter, the tree breaks from B point to C point is the broken part. It touches the ground on the point C and makes angle 60 degree with the ground. Now it says what is the total height of the tree here? Total height means x. Total height we have to find out. This is x. Suppose I have taken x plus 15 minus x means 15 meter total height is. Total height is this. We have to find that at what height the T is broken. So this AB we have to calculate. Now it says at what height from the ground will the tree break? That means this. This x is the height at which the tree